Hi everyone! So today we're going to be going over another inclined plane question. So this one's going to involve some friction and some kinematics as well. So let's get started. So the question is, Genevieve, 65 kilograms, is skiing down a steep mountain where mu is 0.3 and an incline of 60 degrees. Calculate her acceleration, and if the mountain was 105 meters long from the top to bottom, how long would it have taken her? And what does mu have to be in order for her final velocity to be 10% less? Okay, so let's get started with the setup. So the first thing we want to do is to draw a diagram of what's happening. So if that's our incline and the angle is 60 degrees, then we have Genevieve over here who is sliding down. All right, so then we want to draw a free body diagram to see all the forces acting on her. So we have her right there, and Fg, of course, is pointing straight down. Then we have Fn going out of the page, and friction. So since she is going to be sliding down, friction is going to oppose this force. So the vector will be in the opposite direction, pointing up like this. All right, so now we want to draw a vector addition diagram and add up all of these forces. So we have F of G going straight down, then Fn, like that. Then we can draw F of friction, and then the F net vector, which is pointing straight down like this. All right, so that's our setup. So let's go ahead and start our first question. So the first one says to calculate her acceleration. So recall that we can get acceleration from force diagrams by solving for F net, because F net is equal to ma. And recall that from before that this is a right angle triangle. So we can use all of the trig properties associated with right angle triangles. So according to this angle over here, which is 60, right, because this angle here corresponds to the angle right here on the diagram. So this side over here is opposite to it. Fn is adjacent and Fg is the hypotenuse. So what we could do is write sine of 60 is equal to this side over here, which is equal to F of friction plus F net all over Fg. So we can solve for F net first, and then we can grab the acceleration from there. So now this is just a matter of algebra, so let's go ahead and solve for F net. So we can move Fg over here. So we get Fg sine 60 is equal to F of friction plus F net. Then we can move over the friction. So it's going to become Fg sine 60 is minus F of friction is equal to F net. And now let's go ahead and break up all the individual components. So remember, Fg is just equal to mg, and friction is equal to mu times Fn. And so we don't know what Fn is, but remember we can still use one of the trig properties. So Fn is adjacent to this angle, so we could write cos of 60 is equal to Fn over Fg, and we just move that over, so that becomes Fg cos 60 is equal to Fn, and this right here is just equal to mg cos 60 is equal to Fn. So we can just actually go ahead and plug that into here. So just get rid of that, and you get mg cos 60 is equal to F net, and remember F net is just ma. All right, so note that you can just cross out the m's because they occur everywhere. So now we're just left with a is equal to all of this. So I can rewrite that. So a is equal to g sine 60 minus mu cos 60. And I'll go ahead and calculate that. Okay, so I get 8.337 meters per second squared. So that is Genevieve's acceleration. Pretty fast. Okay, so let's go ahead and start the second question. So this one's asking if the mountain was 105 meters long from top to bottom, how long will it have taken her? So this is a pure kinematics question. So let's go ahead and state what we know and what we don't know, and then figure out how we can find the variables that we don't know. So the ones we know is that the distance is equal to 105 meters. Acceleration we found from last time was equal to 8.337 meters per second squared. And the initial velocity, we can assume that she's starting at rest, so that's just equal to 0. And what we don't know is time, of course, and we also don't know the final velocity, but I don't think we really need that. All right, so let's look at which equation would be the best suited for this. So we have distance, we have acceleration, and the initial velocity, and what we need to do is find time. So the most appropriate equation would be this one. So d is equal to vi times t plus 1/2 at squared. All right, so let's go ahead and plug in the values. So we have distance is equal to, move it over here. So distance is equal to 105 meters, and this is equal to 0 times t plus 1/2 at. So this is 8.337 meters per second squared times t squared. So this cancels out, and what we get is 105 meters is equal to, let me go ahead and calculate that. Okay, so I get 4.1685 meters per second squared, t squared. So all you need to do is divide this over, so you can do that. 4.1685, 4.1685. These cancel out, and what we get is 105 divided by that value. Get 25.188 is equal to t squared, and of course we need to square root both sides. So I get t is equal to 5.01. I'll just round it to 9 seconds. All right, so that's how you do this question. All right, so let's go ahead and solve our final question. So this one's asking, what does mu have to be in order for her final velocity to be 10% less? So we're solving for mu, so what we want to do is, first off, find out what friction is equal to. So remember, just like we solved for acceleration using Fnet, we can use that same expression, which is sine of 60 is equal to friction plus Fnet all over Fg. And we can go ahead and try and solve for mu. So if we do that, we can just move Fg over and minus Fnet. So what we get is Fg sine 60 minus Fnet is equal to F of friction. All right, so let's go ahead and break down its components. So we get mg sine 60 minus ma is equal to mu. And remember, this is mu times Fn, but Fn from before, that's just equal to mg cos theta, right? So we can just write that. So mg cos theta, or 60. Just write that in. All right, so note, just like before, the m's cancel out. And then we can divide over the g cos theta. So what we're left with is g sine 60 minus a all over cos theta g cos theta is equal to mu. Okay, so we do have technically everything except acceleration, because now our acceleration is different because the velocity that we want to find has to be 10% less than our previous velocity. So this now becomes a kinematics problem. So let's go ahead and solve for A. So how we're going to go about solving this problem is first we got to figure out what her final velocity was last time, and then figure out what is 10% less of that. And then from that we can solve for her acceleration and then plug that into here and then get our mu. So let's go ahead and do that. So let's write out first what we know, which of course A, which we found from last time, was equal to 8.337 meters per second squared. So this is her old acceleration, and the time was 5.019 seconds. Velocity initial is the same, 0, and the distance as well is the same, 105 meters. And then what we don't know is the old velocity, and the velocity, which is, so it's 10% less, so it's going to be 90% of that, and the new acceleration, AN. Okay, so first what we'll do is solve for VF and then solve for it where it's 10% less, and then find the acceleration and then plug that into here. So let's go ahead and first solve for VF. So technically you can use any equation you want because you have so much information. So let's go ahead and use the most simplest one, which is this. So it's VF is equal to VI plus AT. Okay, so this is just 0 plus 8.337 meters per second squared times t, which is 5.019 seconds. I'll go ahead and calculate that. And I get 41.843 meters per second. So, and that's our VF. Okay, so this new VF, so it's going to be 10% less, so it's going to be 90% of the old one. So what I can do is just do 0.9 times VF, which is just 0.9 times 41.843 meters per second, and I get 37.659, I'll just round it to 66 meters per second. All right, so now that we have VF, let's go ahead and solve for the acceleration. So time will be different because you have different acceleration and final velocities and whatnot. So we don't want to use the VF is equal to VI plus AT formula because of that. So we're going to resort to this one. VF squared is equal to VI squared plus 2AD. And we can grab the acceleration from there. So usually I would just try and isolate the acceleration first, but because this is just a really simple equation, we can just go ahead and plug the values in. So VF from before is equal to this, so we get 37.66 meters per second squared is equal to 0, which you don't need, times 2 times A times 105. So if we just divide those over, what we get is 105, then divide this by 2 times 105, so these cancel, so acceleration is equal to, I get 6.753, I'll turn it to 4, meters per second squared as your acceleration. All right, so let's go ahead and plug that back into this equation and solve for our answer for mu. So get mu is equal to 9.8 sine 60 minus 6.754 all over 9.8 cos 60. And that's going to give you 0.354 rounded. That is your final answer for that. Thank you very much for watching. Hope this helped. If you have any questions about this question in particular, go ahead and write them in the comments below. And also, if you want me to do any other physics question, let me know as well. Thank you.